Hello, my name is Sam. I'm the technical artist and Unity developer for Voxon. In this video, I'm going to take you through the process of building a simple Suika game. It's like a little physics dropping match sort of game for the Voxon displays. This video is going to run through the process of setting up the Voxon plugin for Unity. In the first instance, if you haven't done so already, you'll need to go to voxon.co, go to Downloads, and download the VLED environment. Run through that installer, and then once you've finished that, it's a good idea to just reset your computer to make sure that any changes to the registry are applied through and through. Once you've installed that, you'll need to go to the VLED installation directory, go to SDK, Plugins, Unity, and you'll find our Voxon Unity package. Double click on this, and you'll be prompted to open it up in Unity. There's a lot of stuff in here that we're not going to be touching today, a lot of sample scenes, test assets, that sort of thing. We're just going to be running through the very basics in this instance. Once that's complete, you'll now have a Voxon folder. This will have pretty much all of the data and DLLs and bridges and conversions that we're going to need to work with the Voxon hardware. It's fairly simple on our end. All we need to really worry about are the prefabs and the shaders. So in the prefabs folder, if you open that up, you're going to have two assets. You'll have a Voxon capture volume and a Voxon lit renderer. These are going to work together to capture the data within our Unity scene and present it within a display. So I'm going to drag in a Voxon capture volume, and that's going to give us a little wireframe cylinder. This is going to represent the bounds of our volumetric display. Anything that is captured within this boundary is going to be something that can be shown in the display. Anything outside is going to be disregarded data. There's a few aspects in here that we need to just be mindful of, specifically that the position, rotation, and scale of this object are going to reflect changes to the display. So if we rotate this volume, it will represent all of the scene being rotated in the display. If we move this volume, then it's going to pan and shift everything as if we're moving the camera for everything in the display. If we scale it, it's going to be the inverse. So a small volume shows objects bigger, a big volume shows objects smaller. One thing to bear in mind though is that the scale is determined by the VX capture volume object. We'll get to that in just a moment. I'm just going to right click on my transform component and click reset just to bring that to the center of my scene. Now taking a look at the VX capture volume object, the camera shape is going to determine the aspect ratio of our capture volume. So at the moment it's set to lock to hardware. So this means that it's going to use our VLED runtime ini settings and set the bounds to that. If we're using a system that is not our target system, so for example developing on a VX2 for a target platform of a VX2 XL, you can determine which bounds you want the system to be forced to. If you need to make changes to the bounds at runtime, if you need to scale the bounds, you can select VX cap cylinder. That's going to give you a custom size boundary that you can modify at runtime. Just making sure that you use the VX capture volume's vector scale instead of the object's transform scale. I'm going to set this back to lock to hardware just to make sure that everything works consistently. The next component on here is the VX hardware controller. We don't have to do too much on here, but we do want to just pay attention to auto start motor. This is a nice setting for if you're doing something for a display purpose, such as an out-of-home entertainment unit or exhibition piece or something like that. You can set this to automatically start the display's motor when the software starts. Since I'm just doing this as a test project, I'm just going to leave that off. So the only other thing that we need to bear in mind is that for each scene, we need to make sure that the capture volume is connected to the runtime. And we can do that by going up to our top menu. We'll have Voxon, come down to Process, and we've got some settings here, but specifically we want to look at capture volume, and we just want to drag in our Voxon capture volume into that capture volume slot. This is going to basically give a listener for the Unity runtime to work out what the data is being distorted and shaped into. It's also a good idea to just come down to the bottom here and turn on VXU handle. It's possible because we're running a DLL sort of in parallel to Unity, that the DLL reference can get lost as we stop and start and stop and start as part of our testing. So if you turn on keep VXU handle, that's just going to make sure that it preserves the old reference and it just keeps things a little bit more stable. Otherwise you need to close Unity, open it back up when it fails to launch the plugin. So the next part is, now that we're sort of defining the bounds of what's being captured, is that we need to be able to get a reference of all the pixel data to convert it into voxel data. And we do that with a Voxon lit renderer. This works as a camera which captures depth data and color data from our scene, and this is going to then be remapped into our capture volume. So we have some normal camera settings here. We've got the background and culling mask just to make things a little bit clearer as far as what we're looking at. The projection is set to orthographic to minimize distortion, and we can just adjust the size to make sure that it fits comfortably over the bounds of our capture volume. So if I run that about, I think it's a little over 30 or something, just as long as the Y value covers it, that should be fine. Great. Then the actual data passing happens in the VX lit renderer component. So this already has a reference to the depth camera, which is just this regular camera object, and the resolution is going to determine the size of the render target that the capture camera renders to. So the greater this resolution, the more potential voxel data you can pull from. I tend to find that the diminishing returns sort of caps out at about 700, but if you go lower, you'll get faster performance, but the display might appear a little bit sparse since it's not capturing quite the same density of data. The aspect ratio can be used to further modify the projection in addition to the capture volume. So you can do a multiplier if you're needing to scale an XL display back into a VX2 display. For the time being, I'm just going to leave this, but that's what those settings are there for. We do want to just be aware that there is a global brightness adjust. This can be useful as a global setting for the overall luminosity of a scene. So if you're finding that everything's a little bit too dim, you can give a multiplier to that value and just set that to something a little bit brighter, or alternatively you could use it as a scene transition and you can dim it down to 0 with just changing one single variable. The last thing to just be aware of is that we do have a force look at VX camera setting. This will run in runtime and it'll just make sure that the camera is always looking at the center of the display. It just keeps things a little bit more manageable, especially if you're moving and orienting the VX capture volume. So now we should be in a position where we can start to add something to our scene. So let's start with the art assets of our project. We're just going to be working with basic spheres and planes for this project, but the pipeline is fairly flexible for simple diffuse only material pipelines. To this end, I'm just going to start by creating my folder structure. So I'm going to right click, create a new folder, and call this one art, and right click in the project panel, go create folder materials, and then last one, create, come down to material, and I'm going to call this M underscore for keeping my project nice and neat, and we'll just call this bubble. Now that's made a standard Unity material, but the standard material isn't going to be captured by our lit renderer. We need to come up to our inspector and go shader down to Voxon VX lit shader, and this material is now valid to be captured by our lit renderer. So to test this out, I'm going to go up to Game Object, 3D Object, Sphere. Just set this back to the origin of my scene. I'm going to scale it up nice and big, maybe 8 by 8 by 8. And I'm going to apply this material to my sphere. If I hit play, this is going to open up our Voxon simulator. You can find some more information on this in the Voxon user guide, but if I hold down slash, that's going to give me some options. I'm going to press B while holding down slash to turn on my boundary, and then I'm just going to use the square brackets to rotate the volume. And we can see here that we've definitely got a direction being captured on our sphere. So we're not seeing the whole sphere, we're just sort of seeing that front face. For lack of a better term, you can almost think of the camera as being sort of a directional light. But we can see that that object is now being rendered within our simulator. Anything that happens in our simulator is going to appear in the display. So I'm going to press escape to get out of that one. And now we can start to build out some of the other objects that we're going to need. We're going to need a floor. So I'll go game object, 3D object, plane. Set this to the origin of our scene, and we're just going to bring that down to maybe -19 so that it's sitting just above the base floor plane. And I'm going to scale this up, I think, to 5 by 5 by 5, large enough that it's going outside the bounds of the capture volume. For this, I'm going to right click again, go create material, and I'll call this m_floor. Again, set this to Voxon VX shader, and I might give this one just one of the standard textures that we have available. I'll use the default checker for this, drag the material onto the floor, and I'm just going to change the tiling to, let's say, 5 by 5, just to give us something a little bit more interesting to see. If I hit play again, we can get a look at how this is in the display, and that floor might be a little bit too bright. So let's take a look at some of these other settings where we can modify either the luminosity cull threshold, which is going to determine how bright any given pixel is going to need to be in order to be rendered by the display. I'm not going to worry about that, but instead I will take a look at the brightness adjust, and I'm just going to turn that down to maybe 0.5. Hit play again, and I can see that floor now, and it's going to be a little bit less intense when it's got all these spheres and bubbles sort of jostling around on top of it. So the last thing I need to do before I start getting into the actual functionality of this game is that I just need to build out some walls. I'm going to do this as simply as possible, and I'm going to do it in a visible way rather than in a neat way. So I'm going to create an empty game object, and I'm going to call this walls. Make sure that this is in the center of my scene, so reset the transform by right clicking and click reset. Game object, 3D object, cube. And I'm just going to call this wall and drag that onto walls. Reset the transformation of my wall object, and I want this position on the Z axis to be about 18, and that's just going to push it close to the edge of the capture volume, but not quite. And the reason why I'm doing this is that I still want the spheres to be whole, even when they're jostling up against the edge of the display. And I'm going to set the scale of this to 40 units tall. So I want this to be tall enough to contain the entire bounds. I might actually do that 42, just to make sure that it's exceeding the bounds there. I'm going to modify the width of this so that it's clearly cutting across, so that's about, let's make it even 24 units. And then I'm going to select my wall, press Ctrl D to duplicate, and this one is going to be at -18. Still with the same dimensions, but this is going to just on the other side. If I select these two objects now, make sure that my pivot point is in center. I'm going to press Ctrl D to duplicate, E to go into rotate mode, and I'm going to rotate this approximately 45 degrees. Doesn't have to be perfect, but obviously neat is going to be a little bit more reliable. Duplicate again, and I'm going to rotate it another 45 degrees to get as close to 90 as I can. Duplicate again, and trying to get as close to 135. So now we've essentially got a bit of a bucket shape. it makes it a little bit hard to actually see what's going on inside our volume now. So I'm going to select all of the wall objects. So select the top one, hold shift, select the bottom one, and I'm going to right click on Mesh Renderer and go Remove Component. Do the same for the mesh filter, and we're just left with a bunch of objects that just have box colliders of the right size. It's not necessarily neat, but it will work. I can close up that walls object by just selecting that triangle, and that's just going to make my hierarchy a little bit neater. That's it for part 1 of this series. In the next video, we're going to be building in the functionality to make the spheres merge and level up when they collide with one another. I'll see you next time, but until then, you can find more information about Voxon in the description below, or you can check out more of our other videos.